Now we are going to do the problem best time to buy and sell stock. So you are given an array of prices where prices of I is the price of a given stock on the ith day. And you want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from the transaction. If you cannot achieve any profit, then return 0. So the problem is to find the maximum profit that you can get from an array of prices that is given. So here the catch is that the price of that day is given and it is a price for only that day. That is, for day 1 you have the price 7, for day 2 you have 1, for day 3 you have 5, for day 4 you have 3, for day 5 you have 6, and for day 6 the price of the stock is 4. So you need to choose two prices from this list to buy and sell a stock so that you will get the maximum profit. So we know that the maximum profit is obtained when you buy a stock or buy any item for the minimum of the price you can get and sell it for the maximum price you can sell it at. So the profit will be that maximum selling price minus the minimum buying price. But what we can do is we can select a day. Suppose we are selecting a day 7, the first day to buy a stock at a price of 7. Then you need to find another day to sell a stock. You cannot sell the stock on the same day. You need to find another day to sell the stock such that the profit will be maximum. So in the given case, we know that if we choose day 1 where the price of the stock is 7, you do not have any other price that is greater than 7 in any of the other given day. It's all less. So when you subtract, you're actually going to lose. You're not going to make a profit. So let's say we are selecting day 2 to buy the stock where the price of that stock is 1. Now you have the liberty of choosing another day to sell the stock where the prices are higher. So we can see that in the list 1 is the smallest price of the stock on day 2. But the problem is if you buy 1, then you need to choose another day, not the same day, to sell the stock. You can choose any day to sell the stock. You can choose 7, 5, 3, 6, 4. But the condition given is that you cannot go back one day to sell the stock. That is, if you choose 1 to buy the stock, so 1 will be our buying price. Let's say this is our buying price. We are choosing to buy the stock on the second day at a price of 1. You cannot go back, since 7 is the maximum price that is in the list. You cannot go back to that 7 and sell it on that day because you cannot go before that day. If you are buying it on the second day, you need to choose either 3, 4, 5 or 6th day to sell the stock. You cannot go back in the first day and sell the stock. So next you need to find a stock price that will yield the maximum profit. So let's see, we have 5, 3, 6 and 4. If we choose 5 as the selling price, we are choosing to sell the stock on day 3 with the price of 5, then the profit will be 5 minus 1, which is 4. Okay, not a bad profit. Now let's go and see what if we decide to sell it on day 4 with the price of 3. Then it will be 3 minus 1, 2. No. So far 4 is the maximum profit that we are getting by selling the stock on day 3. Now let's see what if we are deciding to sell it on day 5 with a price of 6. 6 minus 1 will be 5. So 5 is greater than 4. Our maximum profit so far is 5. Let's see further if we have any more better profit that we can obtain. We are seeing the prices on day 6, which is 4. 4 minus 1 is 3. No, 3 is still less than 5. So we are deciding to sell the stock on day 5 with a price of 6, and the maximum profit thus we will obtain will be 5. Okay, so 6 minus 1 in this case implies we can get a profit of equal to 5, which is the maximum that we have obtained so far. So how will we code it up? So what you have to do is you need to first have two variables that will hold the minimum price that we have obtained so far and the maximum profit that we have obtained so far. So if you were seeing how when I was explaining the problem, we decided to buy the price on 1 at the price of 1 on the second day, and then when we were checking we got 5 minus 1 the third day with a profit of 4. So let's say profit equal to 4, but then again when we are coming through the list we can see that we are getting better profit. So we need some variable to store the current maximum profit that we have obtained so far in the list, so that we can compare that profit against all other profit that we will be potentially getting in the future and decide which one is the highest. So we need a variable for that. Also we need a variable to store the minimum price that we have seen so far, so that if in case we are finding a better price than 1, we need to make that as our buying price. Suppose on day 4 the price surprisingly dropped to 0, then that buying price now will become this 0. So we also need a variable to keep track of the minimum price that we have seen so far. So we solve the problem. We have the minimum price to see if we are actually buying the stock at the minimum price that is possible, and also we are seeing if we are selling at the maximum profit possible by keeping track of the profit we have obtained so far. Now let's go and code it up. So what we need a variable to keep track of the minimum. So for that, before entering the loop, we can say that so far the minimum price that we have seen is maximum, infinity. Okay, and the max profit that we so far obtained is 0. We don't know, we're just giving some random value, but a value such that the minimum price when we are entering the list, obviously we will not have any infinite priced stock. It will be always a number less than infinity. So we can compare that and get the minimum price. Now for price in prices, we are going one by one. Okay, if the price is less than the minimum price, we are seeing if we can use that as the buying price. Let's keep it as the buying price then. I think it will be better, or else let's keep it at that value, because then we'll not be able to differentiate between buying and selling. Then we can say that this minimum price, or let's say that the buying price, that way it will be interesting. Okay, this is the selling price. If this selling price that we have decided, you know what, just keep it as price only, is less than the buying price, then update that buying price as that price. Okay, and then we will calculate the profit. Profit will be this price is the selling price equal to minus the buying price. Okay, and then we check if this profit is greater than the max profit. If yes, then we will update the max profit as this profit. Then at the end of the loop, we just return the max profit. Let's run and see. You can see the two test cases are done. We'll submit. So while submitting, they will run it against many more number of test cases, we can say that you are bet 96.29% and with a runtime of 677. So if you like check the time complexity, we can say that it has a time complexity of n because we are going through the entire list, and space complexity of 1 because no matter what's the size of the list, we are only using up these two variables, so it will be a constant. Okay, let me write that down as well for future reference. Time complexity will be O of big of n, and there you have space complexity of